So I'm Dr. Tolly Jordan in the Department of Biology, and I'm really pleased to introduce Sarah Lagon, who was a student in my freshwater biology class last fall, and she undertook the task with grace and style and excellent data on a project in which all students, our graduate students, had to select 50 peer-reviewed papers on a topic of either national, regional, or local scales to understand water quality and water quantity difference or issues within the U.S. So without further ado, I'll let her discuss her research, but it was a great job.
Well, as Dr. TJ said, my name is Sarah Lagon. I am a master's candidate in the Department of Biology, and I'll be talking to you today about urban runoff and water quality. So, as many of us know, access to water is a human right because many organisms, including humans, are reliant on water for survival. And thus, water quality is a growing issue of importance as the human population continues to climb and climb. I conducted an analysis of 50 peer-reviewed papers to analyze what types of measurements scientists are using to determine the effects of urban runoff on freshwater systems across the United States. So urban runoff can be defined as those anthropogenic or human-made contaminants and wastes which leach into freshwater systems following rain events. And urban runoff has demonstrably negative effects on freshwater systems as it influences the interactions among and contributions of those biological, physical, and chemical components of freshwater systems. So biological components or measurements may include diversity and abundance, fecal coliform presence and absence, as well as represented functional feeding groups in those freshwater systems. Chemical components may be salinity and pH measurements. They may be concentrations in metal ions, organic contaminants, and also nutrient concentrations that can include phosphorus and nitrogen. The physical components of freshwater systems can include a number of different factors, such as altered channel morphology, temperature fluctuations, the amount of received runoff, precipitation, and so on and so forth. So in order to get this analysis started, I first selected 50 peer-reviewed papers from scientific databases, and I compared them across what types of measurements were being utilized to determine the effects of urban runoff on freshwater systems. And finally, I compiled percentage points on these variables into the charts that you see underneath the results section. So this first figure shows the percentage breakdown of the types of measurements being used in these studies. 62% measured physical, where 88% measured chemical, and only 46% biological characteristics. And you may notice that these numbers don't round out to a nice clean 100%. That is because a lot of these papers had a significant overlap in the measurement types they used, which essentially means these papers weren't using just one type of measurement to determine the effects of urban runoff. I also analyzed the scientific approach. So what kind of science are these scientists using? Are they hypothesis testing or not? I found that 66% of the papers I analyzed were actually testing a stated hypothesis, while 34% were reviewing existing literature or suggesting models. And finally, I also looked at the location of the studies across the United States. So where is the science being conducted, and what might that imply? Around 30% applied nationwide because they were reviews of literature or models that could apply anywhere across the United States and didn't come out of a specific region of the United States. But the rest of the areas fell out fairly evenly in distribution. So what exactly do all of these numbers and figures I've been throwing at you mean? And what should you get from it? Or what I hope you get from it? Well, first of all, chemical properties, especially nitrogen concentrations, were the most commonly utilized measurements across all of the papers. So you may think that this suggests a bias towards the importance of chemical properties influencing the effects of urban runoff on freshwater systems. But to designate one factor as more important as the other two is fairly problematic because those biological, chemical, and physical components interact so intimately with one another in freshwater systems. So it's more likely a symptom of how easy certain measurements are to take. Those physical and chemical measurements are a lot easier in comparison to biological, and that's probably what's happening here with the results that I've got. As for the scientific approach, the majority of the papers, scientists are actually hypothesis testing. Science is being done. They're not just thinking about this issue, they're actually going out into the field and doing field work. They're conducting laboratory work to better understand this issue and potentially find some solutions. And an even or relatively even distribution across the United States in terms of study location could also signify that the interest in this issue is broad and widespread. However, that slight Western bias, so all of this here are Western studies, could indicate that areas that are struggling with water quality and quantity are producing more research on this issue. Regardless, urban runoff affects freshwater systems in a very clear way. And it not only affects those biological, chemical, and physical influences on systems, it affects the way that we utilize those systems. Urban green roofs and green spaces have been suggested to mitigate some of the issues that we see with urban runoff, but they're certainly not enough to fully reverse or reduce the effects. So the main point I hope I've impressed upon everybody today is that more research is really necessary for this issue that is going to be continually more and more important as our population climbs. So I truly hope you've enjoyed my presentation and learned something today, and I'd love to open it up for questions and discussion.